Boys and girls, this is Mr. Manise here again with another awesome video, and in this video I'm going to walk you guys through how to work each of the problems on the coordinate geometry quiz review number 2. My disclaimer is always, I would like for you guys to work these problems on your own and then, and only then, come to the video and try to figure out where you might have some misunderstandings or any mistakes that you may have made. Okay, so let's just jump right in here, guys. I don't really have any Clemson gifts or anything this time, any images, but I will say I'm very, very proud of my Tigers. Obviously, Clemson is a football school powerhouse, but this year in 2018, at the time of the video, Clemson just made the Sweet 16 in basketball, which is really, really cool. So very, very proud of them. All right, so let's jump right in here. So on each of these proofs, guys, students love to make these more complicated than they are. And there are only two things, one, two things that you're going to do on each of these proofs. I'm either going to use, number one, I'm going to use the slope to see if opposite sides are parallel. Let me just bring a piece of paper in here. If two lines are parallel, they're going to have the same slope. Okay, slopes have to be equal. If two lines are perpendicular, forming a 90-degree angle, then the slopes will be negative reciprocals of each other. So in other words, one slope might be 3/4, and the other slope would be the opposite negative reciprocal. You change the sign and you flip the fraction. 3/4 and negative 4/3 would be negative reciprocals. So in this case, maybe I'm trying to determine whether or not it's an isosceles right triangle, that kind of thing. For two parallel lines, one has a slope of 2/5, the other has a slope of 2/5. Those would be the same. Okay, that's slope. The only other thing that we're going to need is the distance. Finding the distance between 2 points. I want to figure out, are all four sides of my rhombus the same length? I want to figure out if opposite sides of my rectangle are the same length. Okay, now there's also two ways to find the distance. You can either use the distance formula, which I'll write up here. So distance formula, hopefully you guys know this by heart. That's going to be just the differences of my x's squared plus the differences of my y squared. And I'm not going to go back through and talk about the correlation between the distance formula and the Pythagorean theorem. I think we've already beat that horse to death, but essentially they're the same thing. So you can choose either distance formula or Pythagorean theorem. In this video and on my answer key, guys, I'm going to use Pythagorean theorem for everything because number one, it's quicker, and number two, there are fewer opportunities to make mistakes. When you got the distance formula, you got negatives, subtracting negatives, making double negatives, so many ways to make mistakes and errors. So I'm just going to use Pythagorean theorem, all right, which is, of course, a squared plus b squared equals c squared. Okay. So let's jump right in. Prove that quadrilateral ABCD is or is not a rhombus. Show your work and explain. Okay, so if it's a rhombus, what do we know about a rhombus? I know that all four sides are the same. The first thing I need to do is plot the points. Guys, please take your time and plot these points correctly. I've taught all my students when you go back and plot them, take 5 seconds and double check and make sure you plotted it correctly. A is negative 4, 7, so that's left 4, up 7. All right, so that's A. B is 2, 5, right 2, up 5. C is 0, negative 2. I don't go anywhere on the x-axis. I go up 2. Or excuse me, I go down 2. Negative 2. Negative 6, 1. So left 6, up 1. All right, so that's going to be my C and my D. And before I even draw this, take 5 seconds. Negative 4, 7. Yep. Right 2, up 5. Yep. 0, down 2, yep. Negative 6, left 6, up 1, yep. Just check it. 5-10 seconds is all it takes. Let's grab our straight edge and connect the dots again. Okay. All right, so first thing I do is I look at this and say, something looks a little bit off. Doesn't really look like that's a rhombus. Okay, so I'm already thinking probably not, but I have to show the work and explain. I don't need the slope anywhere on this, guys. I just need to figure out, are all four sides the same? Because if all four sides are the same length, it's got to be a rhombus. It might be a square, but it's definitely at least a rhombus, and that's what they ask us to do. Okay, so I just need to use the distance formula or Pythagorean theorem to find these distances. Okay, so how do I do that? Well, let's take a look at, say, AD. I'm trying to find this length here, AD. I need to, if I'm going to use Pythagorean theorem, guys, I need to make a right triangle out of this, because Pythagorean theorem only works with right triangles. So there's my green right triangle. Okay, obviously that's a right angle right there. Okay, so I just need the sides of my right triangle. So I just count 1, 2, 3, 4, 5, 6, and then this is a length of 1, 2. Okay, so there is my right triangle. So over here, I'm just going to say, okay, a squared plus b squared equals c squared. So this distance AD that I'm trying to find is the hypotenuse of my right triangle. So I'll just say a squared plus b squared equals c squared, but in this case I'm trying to find the length of AD, so I'm just going to write AD squared. Some of you guys may be saying, how do you know which one is A and which one is B? It doesn't matter. 2 squared plus 6 squared is the same thing as 6 squared plus 4 squared, so it doesn't matter. I just need this length squared plus this length squared, and then I'm going to take the square root. That's going to be 4 plus 36, so I'm going to say AD. I'll do this is be the only time I do this, guys, because I'm going to skip these steps for sake of time for the rest of the video. AD squared equals 4 plus 36. So AD squared equals 40. Take the square root of both sides, and AD is the length of the square root of 40. Okay, I don't need a decimal. I just need to see, are all of these the square root of 40 or not? Okay, so let's go to the next one. Let's look at this triangle, AB. Okay, and again, this will be probably the last time that I do this for the sake of the video. Okay, so there's my right triangle for this distance AB. Okay, so let's count. 1, 2, 3, 4, 5, 6. And this is the length of 1, 2. So since it's the same triangle, I mean, really and truly, I mean, in my mind, technically, I know it's going to be the same because it's the exact same right triangle, okay? But I've still got to show it. All right, so this time I'll do the 6 first. 6 squared, a squared plus b squared equals c squared. Okay, same thing. That's going to be 4 plus 36, that's 40. Take the square root. I'm going to skip some steps. So AB is also the square root of 40. Okay, so far so good. Both of those lengths are the same. All right, let's check out BC. Again, I'm not going to draw the triangle here. I'm just going to count. 1, 2, a squared plus 1, 2, 3, 4, 5, 6, 7. Okay, so I got something different there. That's going to be equal to BC squared. All right, that's going to be 4 plus 49, so, and then take the square root. BC is going to be the square root of 53. Okay, so there I'm done. I can stop. Okay, so since the square root of 40 is not the same as the square root of 53, then I'm done. Okay, you guys could have come down here and done the same thing over here. If you had found the distance of DC, you would have also, and I'll do that real quick, just for sake of doing it. 1, 2, 3, 4, 5, 6. So 6 squared plus 1, 2, 3 plus 3 squared equals DC squared. Okay, that's 36 plus 9. So CD or DC is the square root of 45. And then once again, we can see all 4 of these distances are not the same. Okay. All right, so my explanation, I'm going to say no. And this, again, for the sake of video, this will be the last time I write all this out. But you guys will need to write this on the quiz. I'm going to say no, this is not a rhombus because not all 4 sides or not all 4 distances are equal. Okay, so it can't be a rhombus. Okay, so that's what we're looking for, guys, on these kinds of proofs. Number 2, let's plot the points. -2, left 2 up 7. It'll be A. Okay, B will be right 5 up 1. C is 7 down 8. And D is negative left 7 up 4. Okay, take 5 seconds. -2, 7, yep. 5, 1, yep. 7 down 8, yep. -7, 4, yep. If you plot these points wrong, this was asking about a trapezoid, guys. So if you were to make a mistake, if it was negative and you actually plotted the positive version of it, that's going to cause you to get some wild, wacky, crazy figure, right? Okay, so let's say that D was like way down here or something, or let's say you accidentally plotted C wrong, and you're way up here or something. If you get some wild, crazy shape, that ought to be a red flag. They're asking about a trapezoid. Mine doesn't look anything like a trapezoid, so maybe I plotted something wrong, right? Okay, so use common sense there. All right, I want to see if these two sides are parallel, okay, because a trapezoid has one pair of parallel sides. So I need slope in this case, okay? So I'm going to write, you need to check to see if AB is parallel to CD. Okay, how do I do that? I'm going to use slope. Okay, but what is slope? All right, slope is rise over run. Okay, now technically, slope, the slope formula is y2 minus y1 over x2 minus x1. Okay, but that's nothing more than rise over run. If you're one of those students, you want to plug all these points into that formula, knock yourself out. I like to use a common sense, efficient, easy approach. So I'm just going to use my pencil and my fingers to count. If I'm trying to find the slope of AB, and I'm going to go back to this real quick. I know we talked about it in class, but I'm going to say it again. If you're trying to find, some students can't remember whether or not a slope is positive or negative. If we're talking about a company, making money, okay, we got money, and so we got time. Over time, if things are going well, right, the company should make money. That's a good thing. That's a positive thing. My line is increasing from left to right. So that would be a positive slope. If things are going bad for the company and the company is losing money, that's a negative thing. That's a bad thing. That's a negative slope. Okay, so keep that in mind. All right. So I'm going to use rise over run. I want rise. I want to rise first. That's the first thing I got to do. So when I'm trying to find this slope of AB, I'm going to start at the bottom point because I need to rise first. So I'm going to rise 1, 2, 3, 4, 5, 6. That's a rise of 6. And I'm running to the left. 1, 2, 3, 4, 5, 6, 7. I'm going to put a negative 7 because if you count up and to the left, that look at this, my company's losing money, right? The line is going down. All right, so that's a negative slope. So I'm going to say the slope of AB is going to be a rise of 6 over a run of negative 7. So of course we know that's a slope of negative 6/7. Company's losing money. All right, now let's look at the slope of CD. Okay, rise. I'm going to rise all the way until I get horizontal with D. So I got a rise of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that's a rise of 12. And then I've got a run of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's a rise of 12. Again, I'm running to the left, so that's negative. But then I can simplify this fraction, divide the top and the bottom by 2, and yes, I do get negative 6/7. So don't forget to simplify your fractions, guys, because negative 12 over 14, you might say, oh, they're different. No, they're the exact same. Okay, so yes. All right, so I can say for sure it is a trapezoid because the slopes are equal. Okay, but then the question says, okay, if it is a trapezoid, prove whether or not it's isosceles. So I need to know whether or not these legs of the trapezoid are the same length. Obviously, they don't look like they are, but we can't trust our eyeballs. We have to show the math. All right, so I'm going to use Pythagorean theorem on AD. Okay, this is 1, 2, 3. All right, so I've got 3 squared, a squared plus 1, 2, 3, 4, 5 plus 5 squared. That's going to be AD squared. Okay, that's 9 plus 25. Take the square root, and we get the square root of 34. Okay, now for the length of BC, again, I'm going to use this right triangle here. So that's 1, 2, 3, 4, 5, 6. Oops, excuse me. 1, 2, 3, 4, 5, 6, 7, 8, 9. So a squared plus 1, 2. B squared equals C squared. All right, that's 81 plus 4. Take the square root. So CB is the square root of 85. So as we anticipated, the square root of 34 and the square root of 85 are not the same length. So in this case, again, I'm going to skip for sake of time. I'm going to say yes. I'm going to say yes is a trapezoid because the slopes on the parallel sides are the same, but it's not an isosceles trapezoid because these two legs, these two distances are not the same. Okay, let's keep going. All right, negative 8, 5. And we got negative 2, 5. Negative 5, 1. Okay, let's check. Negative 8 up 5. Left 2 up 5. Left 5 up 1. Okay, check. A, B, C. And make sure you label your points, guys. A, B, C. You know, part of math, part of the reason why we're doing all this is to learn organizational skills. Okay, how to organize your thoughts and your processes. Okay. Okay, your boss is going to want to know when you solve something in your job or you work something out, how did you arrive to your conclusion, whether that's, you know, something in literature or whether that's something in math or whatever it is. Can you organize your thoughts on paper? Okay, so they want to know if it's an isosceles right triangle. So the first thing I want to do is figure out, are CB and AC, are they the same length? Okay, all right, so let's check those. All right, so for the length of BC, or I'll start with AC, I'm going to use Pythagorean theorem. I've got 1, 2, 3, 4. Here's my right triangle. That's got a length of 4, and this is a length of 3. I actually don't need Pythagorean theorem. Y'all should know this by now. 3 squared plus 4 squared equals AC squared. That's your classic 3, 4, 5 right triangle. 9 plus 16 is 25. Take the square root, and we get AC has got a length of 5. Okay. All right, for BC, okay, same thing. 1, 2, 3, 1, 2, 3, 4. So same thing. 4 squared plus 3 squared equals CB squared. That's 25. Take the square root. And as we see, they both have these two hypotenuses, or both have a length of 5. Okay, so it's definitely an isosceles triangle. Now, to figure out if it's a right triangle, I need to know if that guy right there on my original triangle is a right angle. In order to do that, I need to look at the slopes and see if these guys are negative reciprocals of each other. Okay. Okay. So for the slope, let's start with the slope of BC. Again, I want to rise first. I want to go up first. Okay, so I'm going to rise 1, 2, 3, 4. That's a rise of 4. See if y'all can see that in the camera. That's a rise of 4, and then I've got a run of 1, 2, 3. Okay, so my slope for CB is a rise of 4 and a run of 3. It's positive because my company's making money. Okay, company's making money. That's positive. That's a good thing. The slope is increasing from left to right. Okay, now I need to look at the slope of AC. So I'm still going to start at the bottom point because I always want to rise first. So I'm still going to rise 1, 2, 3, 4. Still a rise of 4, but now I'm going left 1, 2, 3. So now my run is negative 3. So the slope of AC is still a rise of 4, but a run of negative 3. So I have negative 4/3. So the question is 4/3 and negative 4/3, are they negative reciprocals of each other? No, they're not. If this one had been negative 3/4, then those would be negative reciprocals, but they're not. So you can see in this case it kind of does look like a right triangle. If you turn it that way, you can kind of say, ooh, wait a minute, no, that's an acute angle. Okay, certainly kind of looks like a right angle, but it doesn't matter. We got to show the math. Okay, so my explanation here, again, for sake of time, I'm just going to say, I would say, yes, this is an isosceles triangle because the distances of the two legs are equal, but this is not an isosceles right triangle because the slopes of BC and AC are not negative reciprocals of each other. Okay. All right, we're almost done with the proofs, guys. Keep pushing. Negative 2, 2. That's A. 2, 5. That's B. C is 7 down 4. And D is right 3 down 7. All right, check it. Left 2, up 2. 2, 5. 7 down 4. 3, negative 7. Okay, so yes, this looks like a quadrilateral. Nothing looks crazy. Nothing looks quasi. Nothing looks crazy or out of whack. So I'm thinking, okay, I probably did plot these correctly. They're asking whether or not it's a rectangle. Okay, what do you know about a rectangle? Lots of things. Opposite sides are parallel. Opposite sides are congruent in length. And what else? The main thing that you think about with a rectangle is the 90-degree angles, right? So you could start from a couple of different places. What I would do, guys, is I would start with to see, first of all, do I have 90-degree right angles? Okay, because if I don't have a right angle, then all bets are off. It doesn't matter if these opposite sides are parallel. It doesn't matter if opposite sides are the same length. If I don't have a right angle, then the best it could be would be a rhombus or a parallelogram. So let's start there. So I want to check the slope of AB. Okay, so I have a rise of 1, 2, 3. and a run of 1, 2, 3, 4. So the slope of AB, rise of 3, run of 4. My company's making money. Okay, so that's positive slope. All right, so now let's look at the slope of BC. So I've got a rise of 1, 2, 3, 4, 5, 6, 7, 8, 9, and a run of 1, 2, 3, 4, 5. That's a run of 9 and left 5. This is a run of 3, excuse me, a rise of 3 and a run of 4. So a rise of 9 and a run of negative 5. So the slope of CB is up 9, left 5, which is negative 9/5. Well, are 3/4 and negative 9/5, are those negative reciprocals of each other? No, they're not. And we get to move on to the next problem. Okay, that's all you got to do. All right, so I don't have a right angle there, so it's impossible for it to be a rectangle. If you went ahead and found these opposite distances, that's fine. If you actually go ahead and do this, if you look at actually let's look at the rest of these for a little hint, wink, wink for the quiz. Let's find the slope of DC. That's a rise of 1, 2, 3, and a run of 1, 2, 3, 4. So the slope of CD is also 3/4. And the slope of AD, I'm going to start at the bottom, point 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5. So the slope of AD is also negative 9/5. Okay, so you notice those two guys are parallel because those slopes are the same, so parallel, parallel. 3/4 and 3/4 are the same, so these two guys are parallel. All right, so what would we call this figure? It's a parallelogram, but it's not a rectangle because we don't have a 90-degree angle. Okay, so hint, hint. All right, let's move along. Okay, -2, 7, left 2, down 7, right 1, down 3, right 3, down 8. Okay, check. Yes, yes, yes. Okay, so this was A, B, and C. Okay, they're asking whether or not it's an equilateral, isosceles, or scalene triangle. Well, if it's equilateral, all three sides have to be what? The same. If it's isosceles, two sides have to be the same. And if it's scalene, none of the sides are the same. Okay, so I'm going to need the distance formula. I don't need anything parallel. Obviously, we're talking about a triangle, so nothing can be parallel anyway. So I don't need the slopes. I'm simply looking at the distances. All right, so I'm going to be using Pythagorean theorem here again. So let's find for the distance of AB, I've got 1, 2, 3, 4, 1, 2, 3. So a squared plus b squared equals c squared. Again, this is a 3, 4, 5 right triangle. Square root of 25 is 5. All right, for BC, I've got 1, 2, 3, 4, 5, 1, 2. So a squared plus b squared equals cb squared. 4 plus 25 is 29. Take the square root. So CB is the square root of 29. Okay, so definitely it can't be equilateral. And now let's find the distance of AC. I'm going up 1, and then 1, 2, 3, 4, 5. So that's a squared plus b squared equals c squared. 1 plus 25 is, take the square root, is the square root of 26. Okay, so none of these lengths are the same. So what kind of triangle does it have to be? Scalene. So I would write it as a scalene triangle because all three sides are different lengths. Okay, finally, yes, finally we get to some easy ones, Mr. Manise. Easy ones. My goodness gracious, you better not miss number 6 or 7 on the quiz. All right, I might have to punch you in the ankle or something. All right, so prove that -4 and -12 is or is not a point on the circle. You must show your work. All right, so guys, all I have to do, this is super easy. All you have to do, that's your x and your y, is I'm just going to plug in -4 for x, and I'm going to plug in -12 for y, and I want to see if this equation holds true. Because if that point is on the circle, then it is part of this equation. Okay, so when I stick in a -4, I'm going to have -4 plus 5 squared plus y, which is my -12, minus 2 squared, and I simply want to see, does that equal 197, yes or no? Okay, that's going to be 1 squared, -12 minus 2 is -14. Let's square that. 1 squared is 1, -14 squared is 196, and lo and behold, yes, 197 equals 197, yes. So my answer is yes, this point is on the circle. All right. Number 7, I want to see, this is the same as that thing, except this is the equation of a circle. This is an equation of a parabola or quadratic. So I'm going to do the same thing. I'm simply going to plug in -6 for my x, and I'll plug in the -9 for my y. Okay, so -9 equals 3 times my x, which is -6, plus 5 squared, and then plus 7. There we go. Alright, so I've got -9 equals 3 times, that's going to be -1 squared plus 7. So I've got -9 equals, that's just 1, so that's just 3 times 1. So I get -9 is equal to 10. Does -9 equal 10? Nope. No, it doesn't. So I would say no, not on the parabola. Okay, moving right along. Finally, we get to some transformations. Translation, 5 units right, 1 unit down. So all I'm going to do here, guys, I'm going to take each of my x's, move them 5 units to the right, and move them 1 unit down. I'll do these in green. Actually, my answer key I did in blue. I'll stay true. All right, so each one I'm going to go 1, 2, 3, 4, 5, down 1. And when you transform these points, guys, it's not v anymore, it's v prime. Okay. W, 1, 2, 3, 4, 5, down 1. W prime for U, 1, 2, 3, 4, 5, down 1. T, 1, 2, 3, 4, 5, down 1. And I can connect my dots. Now this says graph the image and then provide the final coordinates, so we do need to write down what these final coordinates are. V prime is 1, -2, W prime is 3, -3, T prime, whoops, 1, -5, and U prime is 0, -3. Sorry, I can't see that. Okay, so that's easy. Alright, number 9 is the same thing, translation, but we're in this mapping form here. So all this is saying is that I'm going to take every x value and I'm going to add 2. So that's a shift of right 2. And then what are we doing with the y's? We're subtracting 4. So that's going to be right 2, down 4. Okay, it's the same thing. Let's go right 1, 2, down 1, 2, 3, 4. That's W prime. Go right 1, 2, down 1, 2, 3, 4. That is V prime, and 1, 2, 1, 2, 3, 4. That is X prime. Again, use common sense, guys. When you get done, make sure that you go back and ask yourself, wait a minute now, does this look right? Okay, do these two triangles look like they're the exact same? Yes, they do. So these two trapezoid looking figures look the exact same. Yes, they do. If I had plotted V prime wrong, if I had plotted V prime, say like up here, then you would say, whoa, wait a minute now, hold on a second. That doesn't look anything like my original figure. Hey, maybe I made a mistake. Okay, so use common sense, guys. Always check your answers. Okay, so we've got our final coordinates. W prime is 3, 0. V prime is 1, -3. X prime is 5, -5. Okay, Let's keep going. There's the first page. First page done. Okay, number 10, reflect across the x-axis. Okay, guys, with these reflections and rotations, the way I taught you guys in class, there are two ways to do this. There's the common sense approach, which I am a big fan of, that I like, and then there's the mathematical rules version. Okay, so if you guys want to study that transformation study guide that I gave you that has all the formulas and the rules and knock yourself out, that's fine. Okay, for the rest of you guys, you can use kind of my common sense approach. All right, the formula way, the rule way, is when you reflect across an axis, then you flip the sign of the opposite coordinate. So if I flip across x, then I'm going to change the sign of the y's. Okay, so x prime would become -3, -3. I'm flipping the sign of all the y's. Y prime will be 2, -4. Z prime will be 6, 1. Okay, but some of you guys are like, oh man, Mr. Manise, I just don't know. I'm not good at memorizing things. I get all these rules confused. Okay, cool. Let's plot the points and we'll do it the easy way. -3 up 3. Right 2 up 4. Right 6 down 1. Okay. Sorry, I'm just grabbing my key here. Okay. All right, so let's go ahead and connect the dots. Connect the dots. Man, at the time of this video, guys, spring break is 2 days away. I know you guys are excited. Can't wait. I'm excited. Can't wait. Be a nice week off. Okay, so now the common sense approach is we are reflecting across the x-axis. That means it's the mirror image here. So if I'm one away here on the bottom side, if I'm one away here, I've got to be one away on the top side. Okay, I am 1, 2, 3, 4 away on the top side, so I've got to be 1, 2, 3, 4 away on the bottom side. I am 1, 2, 3 away on the top. I am 1, 2, 3 away on the bottom side. Okay. So these original points, this is my x, this is my y, and this is my z. So now this becomes my x prime, this becomes my y prime, this becomes my z prime. Alright, so now connect the dots again. Alright, so there's your common sense approach. Just count the distance across the axis that you're reflecting around. And then, of course, let's ask ourselves the question, does this look right? Does the purple and green triangle, do they look like they're mirror images? And yes, they do. So I feel confident in my answer. Okay, number 11, it says write the rule to describe the transformation. So here we're just going backwards. Instead of them giving us the rule and we plot it, now they plotted both the original and the final image, and they're asking us what happened. Did we rotate? Did we reflect? What did we do? All right, so what I would do, guys, I would not use my eyeballs here. Okay, if I were you, I would write both of the coordinates out for each point, and then you can say, oh, I see what they did here. So let's start with the original, the one that doesn't have the ticks, because that's my original image. Let's find the points. E is going to be left 3, up 3. F is going to be same thing, left 3 but up 5. G is going to be right 2, up 4. And H is going to be left 1, up 2. Okay, now let's look at the transformed image. E prime is right 3, down 3. F prime is right 5, down 3. G prime is right 4, up 2. And H prime is right 2, down 1. Now let's step back and let's look at what they did here. Okay, that flipped, that flipped. Okay. -3 here, -3 here, 5 here, 5 here. So in this one they switched the X and the Y. This one they switched the X and the Y. In this one they switched the X and the Y. So basically what we did here, guys, is we took an X and a Y and it became Y and X. Okay, so now this is where you need to know what happens with each of these different rules. If I just simply switch the coordinates, this is the one where we said, you know what, this is where we are reflecting around the line y equals x. Okay, look at this distance here. That distance away, same distance away. Same distance away from the line, same distance away from the line. And here's what I mean by that. These two distances are the same. The distance to that line is the same as the distance to that line. Okay, so this would be a reflection around the line y equals x. Okay, if I'd had an image that looked like this, I say I have like a rectangle here and like a rectangle down here. When I plot the points, I could say, of course this is a little bit more obvious, but after I plot the points and look at the image, I can say, oh, okay, obviously they reflected around the line y equals, or they reflected around the x-axis. Okay. All right, so let's get to the rotations. The rotations. Okay, so I wanted to grab this transformation guide. So I put this together, and just like I taught during class, and we've got all these lovely, lovely rules. Rotate 90 degrees, you're going to switch, the y becomes negative, and this xy, the x becomes negative, blah, 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 blah. If you like to memorize these formulas, guys, same thing, knock yourself out. I'm going to teach you the common sense approach to doing this, which most students, kind of the light bulb goes off and they say, oh my goodness, this is so much easier than having to memorize all these rules like you guys did probably in coordinate algebra. Okay, here's what I want you guys to do. When you are rotating 90 degrees or 270 degrees, okay, the first thing I want you to do is I want you to switch the position of the x and the y, just kind of like what we did up here. All right, so we have plotted these 3 points. So let's come out here to the side and let's write these down. L is 1, 1. M is left 3, up 3. And N is left 4, up 1. Okay. First thing I want you to do, guys, is I want you to switch the x and the y. Okay, I want you to switch the numbers. Okay, so L prime, and I'm gonna leave off the signs. Okay, so L prime. When I switch this, it's still 1, 1. When I switch the m's, in this case, those first two don't really change. It's still 3, 3. But now when I switch the n's, it becomes 1 and a 4. Okay, so the first thing I want you to do is I just want you to switch these numbers. Okay, now the second thing I want you to do is I want you to rotate the point, figure out which quadrant you're in, and then that will tell you what these signs need to be. Okay, it's that simple. You don't have to memorize all these rules. Switch and then rotate. Let's take each one at a time. Let's take point L. If I rotate 90 degrees counterclockwise, I think about turning a doorknob, right? And the reason why we're going counterclockwise is because that's the way these quadrants are numbered. Okay, so when you think about counterclockwise, you literally think about a clock, right? Counterclockwise, I'm going that way. Okay, so I'm going to take each of these points. It's like I'm turning it one quadrant to the left. So I like to kind of underline this and say I'm turning to the left. All right, so if I take this point and turn to the left, I'm in quadrant 1. If I turn it to the left, I'm going to be in quadrant 2. Okay, so if I'm in quadrant 2, let me draw this down here. Let's look at the signs. If I'm in quadrant 1, everything in quadrant 1 is positive, positive. Everything in quadrant 2 is negative, positive. Everything in quadrant 3 is negative, negative. And everything in quadrant 4, holy cow, that was terrible. Everything in quadrant 4 is positive, negative. Okay, so you just got to figure out which quadrant you're in, and then that will tell you what all these signs need to be. So if I go from quadrant 1, turn to the left, one click to the left, I'm in quadrant 2. Everything in quadrant 2 is negative, positive. So, negative, positive. See how easy that is? You don't have to memorize any rules. Okay, let's take M. Okay, we're turning to the left, like you're turning a doorknob. If I turn M to the left, I'm going to be down here in quadrant 3. Everything in quadrant 3 is negative, negative. Negative, negative. Same thing with n. If I turn n to the left, I'm also going to be in quadrant 3, which is also negative, negative. Negative, negative. See how easy that is? Super easy. Okay, number 13. Oh, sorry. I guess we do need to follow directions, huh? We've got to plot these. So L prime is negative 1, 1. Do this in green, negative 1, 1. M prime is negative 3, 1, 2, 3, down 3, 1, 2, 3. That's L prime, M prime, and M prime is negative 1, negative 4. And there we go. There is our turned, rotated figure. All right, number 13, let's plot our points. Left 5, down 4. That's A. B is negative, left 7, up 3. C is right 2, up 6. All right, let's check. Left 5, down 4. Left 7, up 3. Right 2, up 6. Okay. Always check and make sure, because if one of your units are off, guys, that's going to throw everything off. Everything off. Okay, now 270 degrees counterclockwise. Well, a full circle is 360 degrees, right? Well, how much is 270 degrees? 270 divided by 360 is 3/4. It's kind of like, remember when we were doing area of a sector and arc length and all that stuff? 270 is basically 3/4 of a circle. Okay, so one way to think about it is 270 degrees counterclockwise is the same thing as 90 degrees clockwise. Okay, so I'm going to write or 90 degrees clockwise. Okay, it's so much easier to turn one quadrant than having to go 1, 2, 3, turn it 3 times. Okay. All right, so let's list we've got our points listed. Actually, they've already listed the points for this one. Okay, so the first thing that I want to do, what's the first step I want you to do? Switch whenever you do 90 or 270, you're always going to switch the x and the y. So this becomes 4 and 5. And once again, I'm going to leave off the signs. I just want to switch the numbers. Switch the 4 and the 5. We'll figure out what the signs are in a minute. All right, for B, I'm going to switch the numbers. So 3, 7. And then for C prime, I'll switch the numbers, 6, 2. All right, now let's figure out what the numbers are. All right, now we're turning 90 degrees clockwise. So I'm turning everything one quadrant to the right. Okay. So one quadrant to the right for C, that's going to put C down in quadrant number 4. Okay. And what are the signs of everything in quadrant 4? Is positive, negative. So positive 6, negative 2. Okay. I'm turning B to the right. Okay. So B will be in quadrant 1. Everything in quadrant 1 is positive, positive. So just leave it. A, we're going to go one click, one quadrant to the right. So that's going to put A in quadrant number 2. Everything in quadrant 2 is negative, positive. So negative 4, positive 5. All right, so let's plot those points. Negative 4, 5 for A prime. Right 3, up 7 for B prime. And right 6, down 2 for C prime. All right, and there is our rotated figure. All right, so remember, that's only for 90 and 270. If you rotate 180 degrees, then all you do is just flip both of the signs. If you rotate 360 degrees, then you just end up right where you started, so nothing happens. Okay. All right, so let's move on over to the back. I don't know if I'm going to be able to finish this before the bell rings. I might have to go pretty quick here. Let's see if I can speed up here. These are easy. All you do with the dilations, guys, is you just multiply each of your coordinates by 2. Okay. So I got this 2 here. I'm just going to multiply every number by 2. So E prime is going to become 5, comma 2. F prime is going to become 8, comma negative 4. G prime is going to become 0, negative 7. Again, for sake of time, guys, I only have a few more minutes. I'm going to kind of skip this, but you'll just plot the original figure, and then you'll plot the new transform figure. You know what? I guess I'll work this out. I'll go ahead and make 2 parts on this video, guys. Let me just finish this problem, and then I'll do a part 2 here where I just work these last 3. So, all right, so let's go ahead and plot our first 3 points. 2.5, comma 1. Some of you go, oh, what, 2.5? How do you plot 2.5? It's real easy. It's between 2 and 3. Okay, so 2.5. All right, here's 2. Here's 3. Halfway between 2 and 3 will be right here. 2.5, and then go up 1. Okay, don't make that more complicated than it is. 4, negative 2, that's going to go right 4, down 2. And then G is 0, down 3.5. So here's 2, here's 3, and it's between 3 and 4. So there's 3.5. All right, so there's my E, here's my F, and here's my G. So let's go ahead and draw this. Okay, there's my E, F, and G. Like I said, we were multiplying. If this number is bigger than 1, guys, you're multiplying. Okay. Well, whatever this is, you're multiplying. So we're multiplying by 2 here. Over here, we're multiplying by 1/2. All right. So here, when I multiply all the coordinates by 2, I get my new figures, my new coordinates. So E prime is right 5, up 2. F prime is 8, down 4. G prime is 0, down 7. And connect dots. If we're dilating by 2, guys, we're enlarging. Like your eyes, the pupils in your eyes are dilated, gets larger or reduces. So my triangle is getting bigger by a factor of 2. So ask yourself the question, is the green triangle twice as big as the purple? Yeah, it looks like it. So that's kind of a way to do a self gut check to make sure you didn't plot something wrong. Okay. All right, so I'm going to stop there on that one, guys, and I'll pick up with part 2 on this video for the last 3. So we'll see you on the next one.